Hello and welcome on this tutorial. We're gonna build a full text search on entities, and in this session we're actually gonna build our entity model. So currently we still have this Quarkus app, which is basically just bootstrapped REST endpoint that returns some string. So let's create our entity model. I'm gonna create a new entity class under web app entity, and I'm gonna start with the author class. Yes, and that will have two properties. One is just the author name, so the author has a name, and it will have a list of books that he wrote, or she, just called books. All right, and this is a new class that we're also going to create. So create a class named book. Yes, and the book will also have just a name and the number of pages. All right. I'm gonna create a constructor which takes both as input, and I'm also going to generate getters and setters for both. Maybe bring that up, and let's fix that one. And here we're gonna basically do the same. We will have a constructor that takes the name and the list of books, and also generate the getters and setters. Why we need the getters and setters exactly, I will show you in a moment. Okay, but that's it for the moment. And let's update our REST endpoint so it actually returns an author. So I'm going to rename that one to author resource. Yeah, let's rename the tests, change the path, and return an author here. So I'm gonna import that and first create some books. Create some book like Dark Tower, whatever amount of pages, and have another book like it with some amount of pages, and create an author which actually contains both books. So that would be Stephen King, and he contains a list of books. So this Dark Tower and it. And we're gonna return Stephen King. So maybe also rename that one from hello to get Stephen King. Actually, that's what it's doing. Oh hell. So all right, so in the browser, make sure you switch over to the author endpoint, and of course also make sure that the application is started. And it kind of works. This returns us an author entity, but we actually want to see it as a JSON, and this is actually the result of the toString method. So I'm gonna change the return type here to JSON, and now it's gonna fail, because at the moment Quarkus does not know how to return or how to deserialize an object to JSON. So we're just gonna add a dependency to our POM, and in this case it's related to REST easy, so I'm gonna add it next to that, and it's just Jackson. So let's reload that. Oh, the dev mode cannot reload new dependencies. So this is one of the few occasions where you actually have to restart the app, like manually restart it. And here it is. So depending on your browser, it might look something like that, but I prefer this view because it's much easier to read. So now we want to store this kind of data model into a database. And for that, I'm gonna go to the Quarkus website again and check out their guides. They have a whole category on data. I recommend that you check out the config on data sources. I'm gonna skip this one because I know that I want to use Hibernate later on. So I jump in here and it directly provides me with the dependencies that are required if you want to use actually Hibernate together with Postgres. So I'm gonna add these two dependencies into my project. Just gonna add them at the beginning here and restart the application, reload it in IntelliJ, and we're basically good to go. So going back to the author, we can mark it as an entity, and we have to mark this list as a one-to-many relationship. And I'm also gonna give it a joint column name because I don't like the default where it actually creates a third table just to store the relation. So this will be a column named author ID. This will create a column named author ID in the book table. We will see that in a second. And pretty similar here, we can add an entity annotation just like that. That would be the bare minimum of annotations which you need for your entities. Even so, we don't have a database at the moment. I'm just gonna start the application and it will run into an error. We don't have any identifier on our entities because so far we didn't need one. But yeah, once we mark it as an entity, we actually have to provide some ID value. So I'm just gonna create a simple one. Gonna use long. All right, and we need the same for our author. So I'm gonna add that here as well. So this basically should now be able to start our application again. And it's still complaining a bit because we don't have any empty constructor, which is required. And let's just fix that. So it's really just an empty constructor. All right, so now our application should start. All right, so but at the moment we don't have a database. And when you look, when you search here for Docker, it actually provides us with a command to start some Postgres database. But I'm not a fan of these rather long and complicated Postgres commands, Docker commands. So I prefer to have some Docker compose file, which I think makes it much more easy to manage it. So let's create a new directory called Docker. And inside that, create a file named Docker compose. Docker compose.yaml. And actually make sure that you have Docker compose installed. Because you can actually have Docker without Docker compose, and then of course it would not work. Okay, so this tells me it's installed in version whatever. And I'm gonna copy over a configuration for a Postgres service. Gonna need that and some version. So quickly going through it, this will start in a service named Postgres. It will download the official Postgres image version 11 from Docker Hub, and it will create a Postgres instance where we can connect with the user Postgres, which is actually the default. So even if you would remove this line, it would create this user in the background. Password change me, and the Postgres database will be named entity search. And this is just basically mapping the default Postgres port to our host. All right, so now we also need to tell our application how to reach basically all this information, how to use this information so that it can connect to the database. And scrolling back up here, so I'm actually gonna copy all of that over into my application properties here and just replace the values as I configured them in my Docker Compose file. So the username is Postgres, the password is change.me, and the database name is actually _ entity search. So these values have to correspond with whatever you used here. And I'm also going to use this drop and create, which will basically drop all tables. So you're going to use all data on each application restart. Make sure you only use that when playing around and never use it in production, because yeah, you would lose all your data, which is kind of bad. So this is it for the configuration, and we have not started our Docker service or the database inside the Docker. So let's gonna change that. Go into the Docker directory and run Docker Compose up. And you see printed database is ready to accept connections. So let's start our application. Nice, it worked. At this point, it makes sense to have a quick look on the database. And for that, I'm going to use PSQL, which comes when you install Postgres locally. So in case you don't have it, don't worry, I'm just going to show you. We're going to connect with the user Postgres to localhost database called entity search, basically what we just created. And the password is change.me. So if we list the tables with \d, we see the Quarkus application during startup actually created the author table, the book table, and a sequence called Hibernate sequence. And this is basically to generate IDs that we want to use here with this generation strategy. So far, the table is gonna be all empty because we never actually wrote to them. So I'm gonna change that now and create a package here called helper. And into that, I'm just going to copy some data seeder class, which I will explain in a second. So just to go from it top to bottom, this basically makes it managed by the Quarkus dependency injection, similar to what you know from Spring Boot, where you have a component or a service. This makes it transactional because we're going to talk to the database. This is the normal entity manager from Java EE. And this code basically is just copied over from the resource. Only notice the difference. We first have to persist the books before we can actually persist the author. Otherwise, we're going to run into an error. So when I reload the page, it will restart the application in the background. And when I check now for books, yeah, you can see it actually worked. We have 2 books in our database, and we can also check for the author. And we see, okay, we have one author named Stephen King, and it's connected to our books by its ID, which is here 3. And this is the author ID column, which is created due to the joint column name that I defined here. If you skip that one, so if you don't have this one or just remove it for a moment, it would create actually a separate table just to join the ID of the book and the author. And I think this approach is a bit easier to read. Okay, that's it for the actual second part. Next part, we're going to start with Apache Pulsar, and you're there.